Matrices Basics. So we're going to be talking about matrices and how we can use a matrix to solve different problems. So matrices are tools that represent, manipulate, and analyze linear equations. It's very much like the cells in an Excel spreadsheet or a Google spreadsheet if you're using it mathematically. One of the nice things about a matrix is you can take a fairly complicated looking system of equations like this one that has 3 variables, x, y, and z, and you can actually represent it as a matrix. So if you'll notice, the coefficients are the numbers that are in the matrix. So the coefficient of x is a 1, coefficient of y is a 1, coefficient of z is a 2, and it equals 9. So that's how the first row was created. If you look at the next one, coefficient of x is a 2, of y is a 4, of z is a -3, and it equals 1. And it does the same thing with our last row too. That is how your matrix is created. So you can use matrices to represent systems without the variables, and we'll get into what you can do with them later. So if you're talking about the size of a matrix, you always name it by the rows and then the columns. So how many rows there are times how many columns. So this first example has 3 rows, so row 1, 2, and 3, but it only has 1 column. So this is 3 rows and 1 column. This other one has 2 rows and 3 columns, so 2 rows and 3 columns. Now, one of the things you can do with a matrix is it's called scalar multiply. Scalar means that you're multiplying it by a constant. So let's just say that matrix A, and we can give a matrix a name, is this particular matrix here that is 2, 3, 4, 7. If I wanted to find 2A, all I have to do is multiply all of my elements of my matrix, the pieces of my matrix, by 2. So 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8, and 2 times 7 is 14. So that is the new matrix of 2A. If I wanted to find this following matrix, putting a 4 in front of the matrix means I'm going to multiply everything by 4. It's kind of like a distributing problem. So my new matrix has the first number of a 4, then a 12, and then a 20. So those are scalar multiples. It just means multiply everything in your matrix by whatever the scalar is, the constant. Now we can add and subtract matrices, but the only time that we can do that is if their size is exactly the same. If their sizes don't match, then there's not going to be pieces in the right spot to actually add or subtract them. So we add and subtract corresponding numbers. So what that means is if I wanted to find A plus B, the upper left and the upper left are going to be added. So 2 and -4 being added together is -2. And then I'm going to keep going. So 1 and 3 added together makes a 4. 0 and 5 added together makes a 5. And 3 and 1 together makes a 4. So I've just completed my first row, adding them together. So I'm just going to keep going, make sure that you also know how to add it. Hopefully you can figure out where I'm getting these numbers. If you're not sure, ask. And that should be what you get when you complete your A plus B matrix. Now let's say we wanted to do A minus B. It works the same way, except this time we're going to subtract. So 2 minus -4 is 6. Be careful with your negatives. 1 minus 3 is -2. I'm using the same colors from the previous, if you didn't notice. 0 minus 5 is -5. And 3 minus 1 is 2. And the order does matter because it says take matrix A and subtract matrix B. So I need to go the A minus the B. So if I kept on going, I would have a -3, a -2. Again, be careful with your negatives, especially subtracting a negative. -4, 11, and -5. So that's how you subtract matrices. And again, if it wasn't the same size, you would have a number with nothing to correspond to. So it has to be the same size.